Hey, this is Brock Lemire's. We're continuing our study of embedded systems design. We're looking at the serial peripherals on the MSP430, specifically the UART receive. In this video, we're going to do our first example of using the UART receive. And what we're going to do is we are going to send ASCII characters from the computer terminal into the MSP430. And then what we'll do is we'll toggle an LED when we press T. Okay, and then when we press any other key, we'll see information come in. We just won't do anything. Okay, and so here's kind of the setup. Let's go ahead and configure. Let's configure the clock to be 115-200 baud. We'll do that by selecting the SM clock, prescaler of 8, modulator setting of D600, and we will use, whenever you press a key, it's going to send information down the application UART, and then it will go into the receive pin of the peripheral A1. And then when it shifts in, we'll have to be notified somehow. So what we'll need to do is set up the receive interrupt, and every time there's a new character that's ready to be read from the receive buffer, we'll execute an interrupt service routine, and that interrupt service routine will go in and say, hey, are you lowercase t? If you are, I will toggle LED. If you're not, don't do anything, okay? All right, so that's kind of our marching orders. So let's go ahead and fire up CCS, and we'll go File, New CCS Project. And let's see here. So we're in the language C, we're doing UART, and this is gonna be our first RX example. So we'll call it RX1, and then we'll go toggling LED1. Okay, and we're gonna do C, finish this buddy up. All right. Okay, so here's our skeleton. We go ahead and nuke that little comment header, and we're off and running. Okay, so first and foremost, we need to set up UART A1, and we're using A1. Remember, this is the application UART. That's why we have to use this one. Okay, so the first thing we want to do is put A1 into software reset, and we do that by going into the UC, I think I can interpret it as universal serial. Universal serial A1, and then it's the control word 0 register, and I do a bitwise OR in order to set the UC software reset bit. Okay, and that puts it into software reset so that we can do our configuration without it accidentally shifting anything out. Now let's set up our clock. So we're going to go into UC A1 control word 0 register again, and we're going to set a bit with a mask called UC SSEL __ SM clock, and that sets BR clock is going to now be equal to 1 SM clock, which is 1 megahertz. Ultimately, we're trying to get to 115-200 baud. SM clock is 1 megahertz, but we're going to now set the prescaler. So the prescaler is in UC-A1 baud rate control word, and I'm just going to drop an 8 into there, and that's the prescaler. And so I'm going to say prescaler equals 8. Now remember, that only will divide by 8 directly if the OS 16 bit is cleared, which we do in this register, and we also simultaneously do the modulation settings that we got from the lookup table in the datasheet. So I go UC A1, and it's the modulation control word register, and I go ahead and I'm just going to drop in the value 0xD600. Remember, D6 is in the upper 8 bits. That's the second stage modulation setting from the datasheet we looked up, and then in the least significant bit is 0, and that puts us into low frequency mode, and we don't use the first stage. Okay, so that is, let's see, so that's going to be set modulation and low freq. Okay, so we've done all this before, so now let's get the ports going. So let's set up ports. Now we want to set its port for bit 2. We want to set function to UART A1 RX. So the receive bit within the MSP shares the pin with port 4 bit 2. And that happens to be the, the RX pin on the header, J101 header on the Launchpad board that goes to the application UART up the cable. And so what I need to do is I need to go into the port 4 function select registers and configure that. So I do it like this. I go port 4, select 1, and I'm going to do something. And remember, these are two registers that work in conjunction with each other. And what I want to do is I'm going to go in there and I'm going to put the port function select as 01. So in order to do that, I'm going to clear bit 2. And then down here, I'm going to set bit 2. And so that's how I was able to get the setting 01 into the port 4 select registers. Okay, so that chose, yeah, so basically now the RX is ready to go. All right, life is good. Remember, we're going to use the LED, so let's set that up. So let's go port 1 DIR, and I'm gonna bitwise OR it with bit 0. And remember, set port 1 bit 0 to output, and that's LED 1. And then let's see, let's clear it to begin. So let's do port 1 out. We'll clear that buddy so that it starts off at a value of 0. So it's off. So I go tilde bit 0. So let's turn off LED 1 initially. All right, life is good. Okay, so that is that's all the I/O that we really have. So let's go ahead and turn on the I/O system by taking out a low power mode. So I go to the power module 5 control 0 register, and I go ahead and clear the lock low power mode 5 bit. So this is turn on I/O, and now we're ready to go basically. So let's go ahead and take this UART system out of software reset. So to do that, I'm going to copy this, and instead of writing a 1 to that bit, I'm going to clear it. So I do a bitwise AND with a inverted mask, and that will officially take UART A1 out of software reset. Okay, so now I'm sitting here and everything's set up, ready to roll, and now it's actually time to set up the interrupt. So set up the IRQ. And we are going to do, we're using the A1 RX, so it's RX IF flag, that's the interrupt. And this is the one that will raise a flag when information has been shifted in and transferred into the receive buffer and it's ready to be read. Okay, and so that interrupt enable is in UC A1 interrupt enable, and I'm going to set the bit, so it's UCRXIE. Okay, so that's local enable for A1 RX IFG. And now here we are. I'm not going to clear the flags. Okay, now this goes against my, this goes against how I like to do stuff, but this is how they give the examples in the data sheet of doing this. So out of reset, the flag is not set. So I'm going to trust that it's not set. So I'm just going to go ahead and enable the interrupt. And what that does is that better return. Okay, so this is the global enable for maskables. And that's the, remember, that's the GIE bit in the status register. And so that turns on all the maskable interrupts, of which only the receive interrupt for the UART A1 has been locally enabled. So that's the only one that goes. The flag is cleared to begin. So the first flag will be when we send a character and it gets received. And then the interrupt service routine, remember, we're gonna read from it from the receive buffer. When we do that, by default, it will clear the flag again. So we don't have to actually clear the flag in here, even though we really want to. All right, so now here's the main looper. And what are we gonna do? We're not gonna do anything. Okay, so let's go ahead and do a main looper, and that's it. We're done. So that's the end of it. So do nothing. Okay. All right, so everything's set up, and now think about what happens when we hit a key in the terminal and we send down a UART character. It's going to raise the flag on the receive enable. So the receive character, whatever it is going to assert, and that will trigger an interrupt. So we need an interrupt service routine. So let's go down here, and we'll go ahead and do, so here's our little separator. So this is our RSRs, and here we go. So the first thing we want to do is we need to tell the compiler using a pragma. So that is like a directive almost. So we say, hey, I need to initialize the vector table for the following. Vector equals EUSCI underscore A1 underscore vector. And you go, holy cow, where'd you get that? Well, remember, it's in this table right here. So if I go back, this is the vector label, EUSCI underscore A1 underscore vector, and that handles all these flags. Well, it turns out the flag we're using is right here, UCRXIFG. And so that's the one we're going to use. Now notice that there's a lot of other flags that share this vector, but we're not using them. We're only going to set up one interrupt. And so that's good. We don't have to concern ourselves with anything else. Okay, now we told it, hey, go set up this vector, but we don't even give it an address yet. So the way we do that is the next line after this statement is going to be the starting address of the routine to put into the interrupt vector. Before I give it though, I'm going to give it this thing. I'm going to do underscore underscore interrupt, and then I give it the routine name. So EUSCI underscore A1. Let's do it like this. Let's do it like this. EUSCA1. This is an arbitrary name, so you can call it anything you want. And then I'm not going to pass anything in, not pass anything out. There. So now that is the label, the address label that will be put into this vector. And then this little buddy right here tells it, hey, when you return from this routine, make sure to use the return from interrupt, because this routine is an interrupt, not a subroutine. Okay, now we're finally here. If we ever get here, that means something got sent down the A1RX line, was shifted in, and we received it. It's like, oh, okay, well, that's nice. What do you want to do? Well, here's what I want to do. I want to see if it's a lowercase t. So check this out. All I do is say if, and I go UC, and I'm going to go to the receive buffer, A1RX buffer, and I say, was it equal to the character t? And by checking it, that's a read. So whenever I access this receive buffer, I have officially read the information and cleared the receive flag. And so just by this little statement right here, I cleared the flag. I don't have to do anything else. Okay, now what? Well, the whole point of this program was that if we send lowercase t down here, we want to go port 1, we want to toggle LED 1. So I'm going to do port 1 out. I'm going to toggle with bit 0, the bit 0 mask. This is toggle LED 1, and that's it. If we get any other character, that's still fine. We still receive it and we'll come in here, but we won't do anything. Okay, so this is just a very simple program. Guess what? That's the end of it. Okay, so we don't have to do anything more because that we've accomplished all of our functionality. All right, so let's go ahead and compile this up and let's clear out our typos if we made any. All right, no typos. Interesting. All right. Ooh. Okay, so it's downloading. So let's go ahead and take a look at our board. So I got my MSP430 plugged in. Of key importance is making sure that these jumpers are all in place, because this is the receive line right here. So this is the A1 receive, and remember this UART just happens to also be routed over here to this chip where it converts the UART into something that looks like a COM port so that it can go up the USB cable and then also be read by a terminal program on our computer. Okay, so the program's on there. Okay, so let's go ahead and run it. And now it's running on there, but at the same point, it's sharing with the USB cable with the debugger. So if I stop it, I only stop the debug session. Okay, and so the program is running, and I can open up a terminal. And so I'm in CCS. I have my terminal open here, but I can go view terminal, and that'll bring up the terminal, which is already up. And then what I want to do is I want to open a terminal session. So now it defaults to COM5, which I'm assuming is the application UART. It was last time. And now this is really interesting because it's like baud rate 115/200. We did set that up to be that baud rate, but we said data size, no parity, data size 8, no parity stop bit. Guess what? We didn't set any of that up because that's the default setting for the UART frames out of reset. And life is good. So we just go ahead and do that. And now what I want to do is, now it's sitting here and I am going to type on the keyboard. Okay, so I'm going to type right now, and let's go ahead and just hit lowercase t. And so here I go. I'm going to hit lowercase t. And now it's sitting here and I am going to type on the keyboard. Okay, so I'm going to type right now, and let's go ahead and just hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I go. I'm going to hit lowercase t. And so here I look at what just happened. LED 1 just came on. So do you see this? Look at this. I'm gonna hit T again, and I'll like hit it hard so you can hear it. It just went off. Oh, it just went on. It just went off. Just went on. Just went on. Just went on. Just went off. Just went off. Just went on. Look at this. Okay, now let me hit another key. So I'm gonna hit like U. Nothing happened. J. I'm hitting any other key on the keyboard, and nothing happens. Life is good. Life is good. Okay, so I'm gonna hit T again. Toggle, 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 toggle. Okay, so now it works. It works. This is awesome. Let's get a little. Let's look at some other stuff though, since we're here. So notice that the T didn't come up on the board or up on the terminal window. There's a couple different functions here that you can set up when you use this terminal. So one of them is going to be called so this toggle command input. So now in this situation, if I hit T, it works like that, but I can actually type T down here, and then it'll only go when I hit return. So see what I did there is I opened up like this little script, or not, little dialog box, and I can type something in there. So if I hit T, it won't send it right away, and I have to hit return in order to send it. Now, this is where I can see what I send, and also I can type in more characters. So what if I hit like TT and then sent it? Did you see that little blip? So this is really hard to see. It's going to be TT. I'm sending 2 UART frames, and it will turn on and turn off the LED. So watch really carefully. Did you see that tiny little blip? I don't know. Hopefully the camera can catch it. But basically, I sent a T, turned it on, and then turned it off as fast as the terminal would set it. Watch this. Let's go TTTT and see what happens. And you see it was a little bit more. Let's see how many we can do here. I don't think it likes that many. Look at it. It's getting brighter because I'm turning it on and off for a long time. So it's getting brighter and brighter. I'm sending just a ton and ton of things down there. Okay, awesome. Awesome. So that's how you actually send strings. Okay. Now here's a one. Let's turn it on with a T, and then let's send like a bunch of characters that aren't going to do anything, and then let's turn it off. So if I hit return on that, it turned on for a while and then turned off. Honestly, I don't know how many of these we can do, but this is so fun. I can't stand it. So let's try to send like a ton of characters. This is probably going to crash the computer. Okay, so let's see how long this takes. Yeah, turn on a little bit longer, whatever. So now what I want to do is I want to see the ASCII characters actually come in from the terminal. One of the things about the serial peripheral is you never really see the data coming in unless you look in the debugger, the way we've had this set up. And so I do want to figure out, I want to see this information. So if I want to see it, I have to actually take the program and kind of halt it. And so scroll down a little bit, and let's go ahead and set a breakpoint at the beginning of our interrupt service routine. So when a character arrives, it will assert the receive flag, trigger the interrupt, it'll come in here, and then it'll break. And then what I can do is, so I'm going to set that breakpoint, and let's debug it again now. And I want to go find the registers, okay? And I'm specifically after the registers associated with the UART, okay? So if I come up into, here's registers, we haven't run yet, and I've got core registers, there's my ports, I keep going, and I finally get down to the universal serial communication interfaces. And I notice that I have, A1, let's see, I have A1, let me not expand that yet, A0, A1, B0, B1. And it's like, okay, there's the 4 in the peripheral. Now look at this, here's A1. Look at all the values in here. Not values, but the register names. So these all look very familiar. And if I scroll down, here's my receive buffer, okay? So I got the RX buffer right there. And notice that I haven't run this yet, and they don't have values. So when I run this, I'm gonna go ahead and go run, and nothing's updated yet. They'll only update when it breaks. Go down to your terminal. Okay, now since we're only sending one character, there won't be too much contention between the debugger and the UART. So we're just going to send one character. Before you send anything, this is critical, this is a really important step, toggle back into the point where you're just going to hit one keystroke and it'll automatically send without echoing it. So let me show you. Don't get in this mode where you have to hit return, and I'll show you why in a second. Go back into this right here. So now when I'm going to hit T, and I'm going to watch what happens. So it's running, and I'm going to hit the key T, okay? And it broke. And now look at what happened. The buffer has 74 in it, okay? And you're like, oh, 74, what is that? What does that mean? Well, that's the ASCII code for lowercase t. And so to see that, let's go back to that table. This is a little small in here, but let's go in here and it's right down here. So here's the lowercase t is 74. And that's the ASCII code for it. And that's awesome. Okay, so now let's go back and let's step it. I'm going to go run. I'm just going to run and it'll basically toggle the LED. So you see it toggle. So it actually did its function. Now it's back in the main loop. Let's send down another character. And so I'm going to send, let's do these ones because we're zoomed in. I'm going to do capital A. And so I should see 41 in there. And so I'm going to go, I'm going to come down here and I'm holding the shift key down and I'm going to hit A. And boom, 41 just popped in there. Now look at it, and it broke. And so 41 came down there. All right, awesome. So I'm seeing the ASCII characters. Let's go ahead and run it again. Let's test it. Let's do capital F. Okay, so that should be 46. So I'm going to go ahead and click down here. It's running. I'm going to go capital F. It broke 46. Okay, so this is awesome. So we're actually seeing the UART characters come in here. Now I'm going to show you something that's really confusing when you first start doing this debugger. So watch this now. So if I toggle the command and I'm going to go in here and I'm going to type T. Okay. Now it hasn't sent T yet. I'm going to go ahead and run this. And I'm getting ready to send T, right? So the way that I'm going to send this T is I'm going to hit return. Okay, so I'm going to hit the enter key. Now watch what happens. I'm going to hit it, and it breaks, and everything's great, right? Except this time, what's in the ARCS buffer is D. Like, oh, that's kind of weird. Well, it must have got screwed up. So let's test it another way. So I go ahead and hit run, and now let's come in here and let's do our capital A. So I got my capital A, and I'm going to send it, and I'm like, okay, hit return to send it. So enter, and it sends it. It breaks it. And the ARCS buffer stayed at D. You're like, what's going on? Is it broken or something? We were seeing the ASCII characters come in when I was in this mode, when I just typed them in. So if I come back to this and I hit run and I hit T, it sees 74 again. And then if I run and then I come down here and I go capital A and I hit it, it's 41. But then in this mode, for some reason, if I run it and then hit T, I go T and I hit return, I see D. It's like, what is going on? And so the capital A, it's like, where's my 41, man? So I hit return, breaks, D. You want to know what's going on here? If I go back to my ASCII table, now this is pretty small here, so bear with me. If I come over here, the code for D is right here. That's actually the carriage return, okay? You know, carriage return, what is carriage return? Well, remember that every keystroke has an ASCII code, even the return key. Now on your computer, you might have a button that's called enter, or it might be called return. They used to actually always be labeled return, but when you hit enter, it actually is an ASCII code, and the code for it is 0D. So that's the difference in this terminal when I get into this toggle command inputs. When I send T down to the board, I'm not just sending T, I'm sending T and a carriage return. And so that's very important, because if we want to, if we're going to type in this mode in the terminal, we got to make sure that our program on the board actually understands that it's going to get a character followed by carriage return 0D, and then we have to account for that somehow in our program. Okay, but the fact of the matter is this: you just did it. You just created a program that's receiving UART characters from your keyboard of your computer by sending this keystrokes through a terminal window, converts to ASCII, blasts it down the COM port into the application UART of the MSP430, that pumps it over into the A1RX, and you're able to look at the characters and respond to them. Awesome job. This is so cool. All right, congratulations, and as always, support my channel by subscribing, and see ya.